Hi, we're here to talk about how to shift and scale a parabola or a quadratic function. These are functions that are shaped like U's and they have an x squared in their equation. They might have parentheses, they might not, but as long as the second power is the biggest power that you see within the equation, this is going to be a parabola. So let's talk about our parent function y is equal to x squared. We're comparing today all of our equations to that one. This is the equation that goes through the origin 0, 0. If you change this equation in any way, whether you put a number in front of your x squared, a number inside the parentheses where your x is, or after your x squared, it is going to change how your graph is going to look like. So let's look at those graphs. This is our parent function, y is equal to x squared. If I change the number at the very end after the x squared, if I add a number afterwards, it is going to change it either by shifting your graph up or down. And this is going to follow the logic where you think it's going to go. So if I say I'm going to change my equation to y is equal to x squared minus 1, where do we normally see our negative numbers? We see them under 0, 0, under the origin. So it logically makes sense that if I change it to x squared minus 1, it is going to move my whole graph down 1. Instead of starting at 0, 0, it's going to start at 0, negative 1. All right, where do I normally see my positive numbers? I see them above 0, 0. So my whole graph is going to shift up 1. So however many, how many units you're going to shift depends on the number that I put in the back. So if I change that to a minus 4, instead of going down just 1, it's going to go down 4. The same with the positive version. If I change it to a positive 3, it's going to move my whole graph up 3. All right, that's the easiest of them all. The second change that you can have is putting a number inside the parentheses where the x is. This moves your graph left and right. If I put a minus 1 inside the parentheses, where do I normally see my negative numbers? I see them on the left side of 0, 0. But be very careful with these. This is the hardest part of this whole assignment. Whenever you have a number inside the parentheses, it's going to do the opposite of what you normally think it's going to do. So instead of going to the left one, where I think it should go, your graph is going to move to the right one. So instead of starting at 0, 0, it's going to start at 1, 0. It's going to move to the right one. Again, this would change if you change the number. So if you put a minus 3, it's going to move to the right 3. All right, same with the positive versions. Normally my positives are on the right side because this is inside the parentheses. It's going to go to the left. It's going to do the opposite of where I think. It's going to move to the right instead of moving to the left. And if I change that number at all, that's how many units it's going to move. So if I change it to positive 6, it's going to move to the left 6. All right, and the last change that you can have is changing the number in front of your x squared. If I change it to a number that is bigger than 1, your graph is going to get very tall and skinny. It's going to get narrower. So that's if I change it to a number bigger than 1. If I change it to a number that is less than 1, but still positive, so that includes all decimals, all fractions that fall between 0 and 1, your graph is going to get more spread out or wider. It's going to get fatter. All right? And again, if I change those numbers, it's going to change how much you're shifting it. So like if I change that 3 to a 5, your graph is going to get even taller and skinnier. If I change it to a 1/5, it's going to get wider. So the bigger the number it is, the more dramatic the effect. All right, notice that earlier I emphasized that it still has to be a positive number in front of the x squared. If I change it to a negative number, now your parabola is going to open down. your parabola is going to make a frowny face instead of making a smiley face. So this is true. If I change it to a -5, it's going to get taller and skinnier, but still going to be flipped upside down. If I change it to a -1/5, it's still going to get wider, but it's going to be upside down. So let me compare all of those. Notice they look the exact same, but now instead of being above the x-axis, it's going to be below it because you're reflecting those upon the x-axis. All right, I'm going to put this graph on the description if you want to use it as some notes. But on your assignment, you're not just going to have one change at a time. You're going to have multiple changes, and they're going to ask you to predict where they're going to shift. So let's say that I gave you this equation. Instead of the parent function y is equal to x squared, I give you y is equal to parentheses x minus 4 parentheses to the second power minus 2. Because inside the parentheses I see a -4, this moves it left and right. Because negatives are normally on the left side, but I gotta do the opposite of what I think because of the parentheses, it is gonna move to the right 4. The -2 is going to move it. Do you think it's going to move it up or down? It's outside of the parentheses, so you got to follow your gut here. You're going to go down 2. The only one that doesn't follow what you think is the one inside the parentheses. So instead of starting at 0, 0, you're starting at +4, comma, -2. That's where your vertex is. All right. Another one that you might see on your assignment is what happens if I change the number in the front to a -3, and inside the parentheses I put a +5. So because it's a -3, it is going to be upside down. Because it's a 3 and it's bigger than 1, it is going to get tall and skinny or narrower. And because I have a +5, instead of moving to the right where I normally see the positive numbers, it is going to move to the left 5. So this is what your graph should look like. Upside down, it moved to the left to -5.